So yeah, this question says, initially there are 5,000 liters of water. Water starts to flow out of a tank at a constant rate of 3 liters per minute until the tank is empty. After t minutes, the number of liters of water in the tank, V, will be what? Okay, cool. So in this situation, you need to start imagining what's actually even happening. Like the previous question with the builder's fee. Okay, so there's a set rule. In this situation, there's also a set rule as well. Okay, but you got to think, what topic are we doing? We're doing linear graphs. Okay, linear graphs, linear equations, and how they relate to a real life scenario. So let's draw this out. So you've got, initially there are 5,000 liters of water in a tank. Let's draw that out. So you've got 5,000 liters of water in a tank. So let's call that 5,000 liters, okay? Starts to flow out of the tank at a constant rate of 3 liters per minute. Okay, so what's going to happen is, so this is situation 1. Situation 2 is the water is flowing out, okay, at 3 liters per minute. Okay, cool. Until the tank is empty. So at a particular point, there's going to be nothing in there. So the volume is going to be equal to 0. After t minutes, the number of liters of water in the tank, V, will be what? Okay, after t minutes, what does that even mean? It says after a set amount of minutes, but they haven't given you the amount of minutes. Now let's look at the options that they have. Okay, it looks like these are all rules. You need to then question yourself, what is this topic about? Okay, linear equations. So what is the general equation for a line? Y equals mx plus c. In this situation, what represents your y? Okay, what are you finding out? The volume. Okay, so your volume. And what's the m? The m is a gradient. It's also known as the rate. So this term here means gradient, okay? So it's a slope, okay? But you got to think, is my gradient going to be positive or is it going to be negative? Okay, think about the question. Now, if you're filling it up, if you're filling up a water, now over time, think about that graph, right? V, and you've got T, okay? You got to think, normally in a linear graph, you have a negative axis on this side and this side. But you got to think about it. Does that make sense to have negative time and negative volume? No. So your graph is going to look like that. Now it says here, initially, if time is here, and that's the volume, and it says initially there's 5,000 liters, it's going to be something like this, right? Now what's actually happening? Water is flowing out of the tank. So you got to think about this logically. If water's flowing out of the tank, is it going to decrease or increase? It's going to decrease. So over time, it's going to decrease like this. That's you thinking about the question logically. And that's why I've told you on a number of occasions to actually think about it carefully. So you got to think about what's actually happening. You're not just simply putting in a formula and plugging in numbers, okay? You have to think about it. The first thing I did was draw it. The second thing is making sense of the question, okay, visually. Water's flowing out. So what's going to happen? The rate is going to be a negative gradient. So what does that mean? What's the equation? It's going to be negative mx plus c. What does c mean? Just from basic linear equations and linear graphs. C means the y-intercept. Okay, do you have what represents your y? Oh, it's the volume. Okay, so where does the line hit the y-axis? Oh, it hits here. Why? Because when time is 0, not when x is 0, when time is 0, the volume is 5,000, right? This is what that means, the word initially. So you've got to make sense of that question. Initially, that means basically this. Basically, initially means when x is 0, y is equal to 5,000. But when it comes to a worded question, what does x and y represent? X represents your t. When t is 0, v is equal to 5,000. That's you making sense. And I think this part is really important to write down. So your C represents your y-intercept. Okay, so you've got when t is 0. So what are we going to fill out here? What in the equation represents your time? It's your x, right? So you're going to fill out here t. Okay, that is your equation. That's your equation of this line. Now you're going to fill it out. When t is 0, which is initially, v is equal to 5,000. Okay, let's write that down. V negative m, t is 0, plus 5,000. So the volume at t is equal to 0 is going to be 5,000, right? So that's why C is equal to 5,000. Next question is asking you, how are you going to find out your M? Okay, we just saw here that the rate of flow is 3 liters per minute. Great. So we're going to write V is equal to negative 3T plus 5,000. So I'll just write that clearly here. V is equal to what? Negative 3T plus 5,000. That is your answer for that question, and it's a negative. The reason why it's a negative is because water's flowing out. So over time, your volume is going to decrease, okay? The change in y over change in x is your gradient. Now let's look at the answers and see which one that matches up with. Let's look at ones that it definitely isn't. Okay, now it says 5,000 t minus 3. It's definitely not that one, so we'll cross that out. Always cross it out. 3t minus 5,000. Okay, we had a negative 3t, so that doesn't make sense either. 5,000 plus 3t, it's pretty close, but we've got a minus 3t. 3 minus 5,000 t, nope. We'll get rid of that. And we've got 5,000 minus 3t. Well, that looks very, very similar to that. The only thing is that this is arranged differently. They've put the y-intercept first and then negative 3t. So essentially the way they wrote it was like this. Y is equal to c plus mx. Okay, so this is how confusing it can get. So it's actually E.